Okay, so we'll start on with our webinar. So this is, as I mentioned before, this is applying Industry 4.0 to the cable factory environment. This is our second webinar in one of our series, and we are delighted about the amount of attendees who are here today. So my name is Pippa Bindon, and Yufei Du is going to be presenting this webinar. So just a few housekeeping rules. So if you have any questions, please click the bubble next to your comment and mark as question. If you have any video or audio issues, please refresh the page and there's a button down below, or try another browser, and Chrome or Firefox is preferred. If it is blurry for you, keep in mind YouTube automatically adjusts the bandwidth, so you may have too much going on at home, so just delete some stuff in the background and it should clear it up for you. And we are hosting a Q&A at the end of the broadcast, so just type your question in the bottom right hand corner and Yufei will answer that in the section. Okay, so just a little bit about the presenter Yufei Du. He is Cimteq's Business Development Manager for APAC. He studied at University of Sheffield doing electrical and electronics engineering, and he now specialises as a software project manager in the cable industry. Is based from a paper he wrote for IWCS this year on applying Industry 4.0 to the cable factory environment. And also some really exciting news, he is moving to our new Cimteq branch office in Shanghai, China in the new year. So Yufei, I'll pass over to you. Thank you.
Okay, thank you, Peppa. And good morning, everybody. This is Yufei Du from Cimteq, and today we are talking about Industry 4.0. Here are some topics we are going to cover today, and about Industry 4.0, what is Industry 4.0, why customer factory needs Industry 4.0 smart factories, and how we're going to implement it. And apart from that, we are also going to talk about does your factory ready to go to the smart factory stage, or if not, what things you might need to think about. And the last one will be what does a smart factory will be looks like. I will give you some very interesting examples of how we're thinking a cable Industry 4.0 could help the cable industry or cable factories. And the first one, why we are doing this webinar, of course, it's because of Industry 4.0, and it's a hot topic. Everyone is interested. And to be honest, for the last years, every visit, I go to a customer site and visit their factories, go to any prospects. They all talking about cable smart factories or Industry 4.0 cable factories with me. We're talking about all the possibilities, and the same question they always ask me is, Yufei, what will be a cable smart factory looks like, or do you have any good ideas, or do you know anyone who can provide you a solution of it? But unfortunately, it's not that straight answer like, yes, this is your answer and here you go. But in this webinar, I will try my best to show you guys in my point of view and in my experience how a Industry 4.0 cable factory could be looks like. And sorry, next. Okay, so yeah, why we need a cable smart factories or Industry 4.0 factory? It's the same thing, to be honest. So from now, if I say smart factory, I mean Industry 4.0 factory. So yeah, I don't know which one you're talking about, but to me, they are the very similar thing. They are the same thing, actually. And what will be a smart factory looks like, and how we're going to implement it. So we're starting with why. I'm not spending many times on it because it's a common agreed that we all know we need a smart factory. We need Industry 4.0 factories, and the time is ready because we have the new technologies as AI, machine learning, advanced robotics, 5G on the way, and we have all this automation robotics to support us. and it's a trend. So the whole industry is going to go to next generation, and as a cable industry, we don't want to be left behind, and we will follow the trend. And the third one, which is the most important one, is the customer needs. We are not quite like the the normal public selling or manufacturing. We sell they focus on the flexible manufacturing, but for us, basically, we have already done this, because if we're thinking the code, the request from our customers is customized cable on request different lengths. Even the same product, you have different lengths when you do. So we already kind of reached that, but if we keep doing on that, we will have, and if we do more smart factory method or applications, then it will be help us as well. So I'm not spending too much time on why, because the important part is how we're going to do that. Okay, so next slides. And before we go any further details, there are two things I would like to emphasize to make sure we are all on the same page. And the first one is Industry 4.0 is not an end solution. It doesn't mean we don't need it. People working hard to achieve Industry 4.0, but it shouldn't be our ultimate goal. Rather than the ultimate goal, I will say it's more like a tool or process or the way of thinking to the cable factories. So it's a path, or it's a way we need to go through, but why we need to go through it is because we want to achieve further. We want to make profits. We want to be improving efficiency. That's the ultimate goal. Industry 4.0 itself, it's not the ultimate goal. That's the first thing. And the second one is all the experience of Industry 4.0 might not able to apply to us straight away. Of course, if we see, let's say, semiconductor industry or the car manufacturers, they have very good practice on how to do automation, and even to a smart factory, flexible manufacturing. They have a lot of experience, but unfortunately, due to our manufacture procedure is a bit unique. So we are not either like semiconductor or cars. We basically assemblies different parts into one goods, and this goods will become another part of the next stuff. All the semi-finished goods will be assembled together, then delivered to our customer. Or we are not like the iron steel making. So it's always the iron, you heating it, adding different additional materials, and checking. It's the same thing, but in different states. And we are not like that. If you're thinking, when we do cabling, it's more like cars, and if when we do extrusion, it's more like a wire drawing is more like the steel part. So we are kind of in between. So I know either side is very good, but we cannot use them straight away. So so until here, you may ask, Yufei, so if it is not working, so what we need to do? And I have something to share with you first, which is how we can implement it in smart cable factories. Although all this experience we can not use, but there is some principle we need to follow. I have summarized them into 5 steps, which I think every cable factory, if they want to achieve Industry 4.0 or smart factories, this is the thing you need to look at. So we're starting at rationalizations and standardizations. The reason why we do it is to control variables. So why we need to control variables is because when we're talking about Industry 4.0, we're basically talking about softwares, we're talking about robotics arms, or all the automation machineries. But before that, there's one step we must do, which is we're putting all our informations, no matter it's a design, it's a manufacturer instruction, or it's just quotation, it's your ERPs. So all of these things need to be migrate from your normal paperwork or Excel or Word to a system. Then you can use the system to talking to no matter the shop floor, no matter to the management level, no matter to your different teams, departments. So when we're talking about Industry 4.0, these are the things we are doing, but we need to have a base. So how we can have it, how we can migrate those things into the softwares, which is we need to first make all our operations, workflow, or even business flow rationalization and standardization. And in this way, we can control the variables. And I can give you a quick example why we need to do that, because Cimteq is a software company. We're selling cable builder, which is a cable design software. And when we're talking to our customers, and we have this quite common because they use Excel to making designs, and they're always telling me, I got 5 design engineer in our teams, but if we ask them to design the same design, they always give me a few different results on the cost, on the time, because everybody do things a little bit different. Yes, it can do almost close, which means we're being past the rationalization. And I believe most of the attendees join this webinar. I think your factory is definitely fine with rationalizations, but for the standardizations, some may have already done, some may not. So that's the part we need to look at, because only you standardize things, then you can tell your software how to do it in a logic way. Because in Excel, you can do anything you want, but after you cannot. And software need to be follow a certain rule, although it can be flexible, but there is limitation. So that's why I would say it's very important your work and your business flow and everything is rationalized, standardized. Then we move into digitalized, which means we use software, and then we use software to control our robotics, we control our AGVs in the shop floor. Then the next thing, because everything is digitalized and we can use that in the factory already, then we're talking about smartification, which is the truly amazing or fascinating part of the Industry 4.0. So that's the path, I will say. No, although we cannot apply all this experience straight away to our industry, but if we're thinking in this way and apply those experience by step, then there is a lot of things can help us. So the next one is, are you ready for Industry 4.0? Let's go back. Sorry, let's go back one more step. So we're talking about when Industry 4.0 is about automation and smartifications. So which means these 3, rationalization, standardization, and digitalization has been done. So how can you tell you have achieved all of this? There are some things I can give you, like a benchmark you can evaluate by yourself. The first one is you have all the systems. For example, at least you have ERPs, which means all your management, your resource is on the system. Then you need to have a PDM, which means your design products is digitalized. You also need an MES, which means your shop floor is digitalized, and you might also need warehouse management. You need customer relationship. You need planning system. All this system, when you have them, you know, okay, you've been digitalized, but maybe half semi-digitalized, because the next thing is all systems sync together, like a one system. I like to use the one system when talking to my prospects or my customers, because this system standalone, yes, they can help you, but it's if you're thinking if they cannot talking to each other, that will be a problem, and you need to let them talking together so they can pass informations. And then you need real-time data feedback, because that's the level we need for the smart factories, because it's real-time, fast react, and everything is up to date. So you need real-time data. And talking about this, and first, before this webinar, I have set up a survey questionnaire. So basically, I'm very thank you for the people have done that survey, and we have some result here. Sorry, I didn't put it's on the paper, but I didn't have time to add into my slides. But yeah, we can go through. So the questions are like, do you have ERP system? Do you use cable design software? If not, do you use Excel? And do you use MES system? Do you have planning system? So all of this is, I ask all of these questions because we want to give you an idea, like on average, where we are. Because, for example, for ERP system, I got totally 13 people finish this survey, and 12 of them have already have a ERP system, and just one doesn't, which means, yes, everybody realized digitalize is very important. And when we're talking about PDM system or cable design softwares, 7 say yes, 6 or no. For the 7 of them, I was hoping you're using Cable Builder, and thank you for support us. But yeah, if not, yeah, talk to us. We will definitely help you. And for those not using cable design software, then they have um, 5 of them is using Excel, and one of them I'm not sure what we are using, but usually Excel is everybody use, and yeah. If you're using that, then you might think about moving it into a PDM system, because if you want your designs to be used on the shop floor, to be used by your ERP or any other parts, you need a software to communicate. You cannot use software talking to Excel. Yes, we can, but it's not the idea of Industry 4.0 smart factories. And then about MES, 4 of them say yes and 9 of them doesn't. And actually, there's an interesting thing. When people talking about Industry 4.0 or MES or smart factory, to me, they always thinking of MES. Yes, that is how important your MES system to a cable factory for the industry to achieve Industry 4.0, because your shop floor is very important. And for most of factories, if you don't have such software helping you to monitor it, it will become like a black box. So that's why you need MES system. And 4 of them have, 9 of them doesn't. And yeah, if you really want to achieve something different, I think MES is the thing you need to look at first. It's a priority. And planning system, very important. We got 7 people have, and 6 not have. And this is very important if you want to be more efficiency. And yeah, that's how. So I will say, according to this roughly, I didn't say it's reflects the whole industry, but at least from this survey, I will see we are on the way, but there is still a lot of things we need to work on to it. So sorry for spending a bit long time on this page, and let's continue. And this is the thing I would like to spend most of time with you guys, which is about what does a smart factory looks like, or will be looks like, or could be looks like. I imagine most of you joined this webinar because of this, and I give you 4 examples. And it doesn't mean only 4 of this 4 link what's the word, leads to 4.0. I just give you examples how we could use the way of Industry 4.0 thinking cable factory, and how we can use it with advanced or latest technologies. So one system I have just talking about your all system communicating together, acting like a system. And I'm not going to oh yeah, to be honest, all these 4 topics can be a separate webinar. If you guys are interested, I would like to introduce one by one to you to details. But for one system, in short, all your system connecting together, working together, acting like one system. And for digital twin, I believe most of you guys heard of digital twins. It's very, very popular at over the place. And it's not only for us, it's for a whole industry. The idea is, after you have the systems, you got all the data, then you simulate your factory in a system or software environment, which means you have identical factory but in digitalized, and you can use that to simulate your manufacture shop floor, to simulate your designs, to simulate even your business flows and all of these things. So this is very, very important. But if you want to do that, you need to make sure you have one system and you have digitalized. Then that is the digital twin. And for the last 2, big data and reinforcement learning, this is something very popular nowadays, but how they can be used in cable factories. I will give you examples on how I consider this and how I thinking of using these technologies, and I do believe it will help you. This is yeah, if you might not seen it before, but yeah, let's take a look about. So first one, big data and neural network. And this is, I believe you know this, but how we can use in KWAS. I will use example for Dr. Lin, who is from Taiwan, and he and his team is working on using the deep learning algorithm, always a neural network, to simulate or verify the service life of robot cables. So I'm not sure which area you come from. You might come from power cable, industry cable, robotics cable, fiber, but it's fine. So I will give you a little bit explain how it works. So robotics cables, it will be used on the robotics arms. You know, the typical industry 4.0 icon, which is advanced robotics arms. And those cable, for his whole lifetime, it will be bending million times. And for those so before we have this method, what we do is we design it based on our experience, and we make a real cable and send it into lab, bend it million times, and then check it is working or not working. So it's the verification period is very, very long. But with the help of the big data and neural networks, because for those factories who making robotics cables, they already have a lot of existing design which are proven working. And if we putting those data into the model we have trained, and with all the parameter, maybe dimensions, material, thickness, the structure of ley length, all these things, and into this model and let it train, and then this model will know how will be the robotics cable can be survive or last for the life cycle. Then for the new designs, what we can use is we got a customer request. Then we design a cable rather than production it on the shop floor, then sending it to testing. We can simulate with this module first, and this module could give you a percentage whether it's likely to be successful or it's likely not to be successful. And with that, so we can basically it tell you how many percentage, the accuracy, how likely it's going to success. It give you not just a simple yes or no. So it's giving you that question. And in this way, it can reduce the life cycle, because if it is after you creating this design, you verify it in your simulation, and you find, oh, it's very low chance to pass the testing, then you might not produce it. You just choose the one which have high possibility then to do the actual testing. And we can do that. So this is the example. And if you are interested in, Dr. Ling and his team is doing this, and they have released a few papers to show this. And if you're interested, there's a more information you can go through, and the result is very positive. So that's using big data. Okay, so next one, which is about reinforcement learning. So this is the thing even further. I will say, actually, it's my own generated idea, but I think it's very good. So I share with you guys, and I have to make sure it's working. I have also have a discussion with a post PhD in study in Harvard, and his major is on artificial intelligence and reinforcement learning, to discuss with him about this idea. And I was getting positive feedback. He thinks it will working for cable industry, and we are thinking of doing more studies on it and try to help out. So what is this one about? I will use this is the latest news case study from the DeepMind, if you know, who is who created the famous AI called AlphaGo, who can play Go's and play the world champion, beaten the world champion in Korea, in China as well. So this is their latest news. They use the same reinforcement learning methodology to play a game called StarCraft 2. And basically, from the news, they can beat 99% of the online players, I mean, the human being players in this game already. So what that has to do with cable industry, is it? So how can this RL, short for reinforcement learning, short for RL, how can this thing help cable industry? It's interesting. Let me do a bit explanation about. So so I'm not sure if everybody is familiar with it, although it's very popular, but I will give you the short explanation. What is reinforcement learning? So if you see the picture on the right side, so that is to basically to help you to do the decision making. So what you need is three states. Three contributions. One is called states, one is called reward, and one is called actions. States means your conditions, and actions is what you do, and then reward is what's the result. And you put that into agent, then reflecting to an environment, then they give you the result. So it's kind of like deep learning, but it's more specific for the certain environment, like a game, because the rule is there, or like a Go game, which is um, uh, like a chess, which is the rule is confirmed, the environment is confirmed. So you can use that. You can put all those data into it to tell them what I want and to train it. Then after if you got enough data to that, then you can have your result. So basically RF is giving you possibilities to help you to making decisions. So why this reinforcement learning can help cable factories? Because if we want to use RL, there is a certain criteria you can use. For example, I will give you some example which they cannot use it. For example, for automation driving, you can use it some way, but not real time, because when we're talking about next level automated driving, auto drive, it's fully depend on machines, and the tolerance of error is very, very low. And you cannot use reinforcement learning because it gives you percentage. If sometime it give you 80% on the decision and you just use it, follow the instruction, you might have some issues. So when we're talking about those very low error tolerance stuff projects, we don't use cable factories. We don't use RLs. But for example, I know when I'm talking to this postdoctor, PhD, and he was giving me an example of how they using this RL. What they do is they trying to helping the hospital. Sorry, I just trying to help the hospital, booking system. It's very sometimes they book the appointment but never show up. So how they can improve that? You have different ways: call, mail, text, even digital message, or even Facebook message. So what's the right order? What day to doing that? There's a lot of options there, and you need to decide what's the best way. So they use the data, which is who come to the hospital to attend his appointment and who doesn't, and what's the order we remind them, and using that to training a agent and using the specific environment, then they have an idea. So in this order, typically, and then we have the highest possibility people will attend his appointment. And if you're thinking about that, do you think it's very similar like cable manufacturing? for example, routings. So for the same design, usually you will have maybe for the experienced manufacturer engineer, you will have 2 or 3 alternative of routings, and you either go from this wire drawing to that extrusion, then do this and do this to deliver the whole thing, and you have another alternative with using some other machines to do making the same cable. So which one is most efficient? And I can give you another example, which is for designs. So when we receive a customer request, so I want this spec, give me the cable of design. You have different way to design it. You can decide which design engineer going to pick up this job, who has the most experience on it. So now those kind of informations, and they are all based on our experience. But for the reinforce, what's the difference of reinforcement learning is the vision. So use the back to the example. Sorry, back to the example I just mentioned about routings. So basically, for human beings, we basically could predict the next 5 step, next 10 step of the for things. When we do prediction, we can do the next after. So we can do a few steps, 5, 10 maximal. So in cable manufacturing, we can decide routings. So we know this wire drawing machine is faster than another one. This extrusion machine is more standard, producing this kind of product. But 5, 10 is our maximal. But with a reinforcement learning condition, the computer can do the same thing, but in 5, 50, 100, or even 1,000 steps future, which means now we choose 2 or 3, we pick up between 2 or 3 possibilities, is because the human beings capability can do that. But with the reinforcement learning, we can enlarge the solution from or the options from 2 to 3 to maybe 10, 20, 30, or even more. And for those one which we cannot see is because the limitation of human being. But for the artificial intelligence, for the software, for the reinforcement learning, it's enlarge our possibility and enlarge our vision. So back to the gameplay, StarCraft 2, why they can beating us, it's not because they become better, faster than the accurate, they call APM to evaluate. They don't have a better, faster, accurate, more accurate. It's just they can sink in further than human beings at that game. They know maybe what's happening for the next 30 minutes. For the normal human being player, it can only think of 2 minutes. So that difference is making the AI unbeatable under that situation. So in our situations, we can also know, okay, so when we have this reinforcement learnings, we might think, oh, why the machine, the RL is not picking up the fastest one? Because it might be the fastest one is not the most stable one, and he is trying to optimize the final goal to the best possible, as deep as possible with long. So that's how they could help us. So the benefits of RL, I have also mentioned, is the vision of it. Is help us when we're making decisions, help us see further, deeper, wider. And the interesting of it is, if you want to know why the RL making this decision, what it depends on, why it doing that, we can even know, they can tell me. So it can help us to enlarge our knowledge or understanding of what's the best, how to pick up best practice of routing. So reinforcement learning can help, but in a very different way. It's not like straightforward thing you can see, but for long term, it definitely bring benefits. So that's the end of our webinar. The conclusion is the cable industry need a smart factory, but in a little bit different way. Because do we really need automations? In my mind, maybe not, because if we're thinking about the breakdown of the BOM cost for a product, labor is not major part, material is still the very major part. And automation maybe not, but for the like big data neural network, reinforcement learning, the system, if we think in that way, there's a lot of things could help the factory to be more efficient, better quality, more consistency, making more profit. And thank you. That's end of the presentation today.
Thank you very much, Yifei. That was a great webinar. So now we're just going to do a Q&A. So if anyone has a question for Yifei, please just type your message out on the right-hand corner and we will get to you. Thank you. Okay, yeah, so we're just going to do a quick Q&A. So just type the question in the chat box on the right-hand side. And if you have a question for Yifei, we'll get back to you. Thank you. We'll just wait a few moments. Okay, everyone, so that's the end of the webinar. Thank you, everyone, for attending. I really appreciate your time. So if you want to book a one-to-one demonstration, go to Cimteq/book a demo for a demonstration on Cable Builder or Cable MES, or email Katie Harrison, katie.harrison@cimteq.com. Thank you very much.